Hi, welcome back. So here we have a brief comparison of Piaget and Vygotsky. The social cultural context, Piaget had little emphasis on what was happening with anyone else, just on what the child was learning and how the child was learning. Vygotsky had a strong emphasis on the social cultural context and who the adults and more skilled peers were in a child's environment. Constructivism, Piaget believed that children were cognitive constructivists. Vygotsky believed they were social constructivists. So Piaget believed the child was building knowledge. Vygotsky believed they were building knowledge in the context of relationships. Piaget strongly emphasized stages of development. Vygotsky had no general stages of development that he proposed. The key processes in development and learning for Piaget were equilibration or equilibrium, which means I'm solidly comfortable in the knowledge I have. Schema, an idea of different pieces of information related to a topic. So a child may have a schema about a dog or a cat. Adaptation and assimilation, the different ways new knowledge is taken in. And accommodation, those were all his terms. For Vygotsky, the big terms we think about are zone of proximal development, scaffolding, how language and dialogue interact with learning, and the tools that a culture uses for learning and how they use them. The role of language with Piaget was minimal. Language provided labels for children's experiences in egocentric speech. For Vygotsky, the role of language was major. It played a huge role in the shaping of thought for children. There are teaching implications. In a classroom for Piaget, you would support a child to explore their world and discover knowledge. For a classroom in Vygotsky, you would establish opportunities for children to learn with teachers and more skilled peers available. So let's move on to thinking about information processing theory. We're going to go back to that a bit and thinking about how schools are structured. Information processing theory, remember, compares human thinking processes by analogy to computer analysis of data. Like computers, people sense and perceive large amounts of information. They seek specific units of information as a search engine does. People analyze just like software programs do. They also express their conclusions to another person so that they can understand them as a networked computer or printout might. So in here you see a graphic of a child with sensory registry. So they're registering the information that's coming in and encoding it. The executive control processes is the way the brain processes the information. The perception goes into short-term memory and working memory in the temporary storage, and then moves information into long-term memory and what we've learned. When we're in working memory, we're retrieving active memories from long-term memory. And so they said this is very similar to how a computer operates. Computers were actually designed by humans, so that process and the way it's described for computers, of course, was designed thinking about the human brain as well. Information processing theory, there's evidence of the theory's usefulness. We can see gradual brain growth in neurological scans in the growth of knowledge and information. There are central processing hubs built over time with practice and learning. They're automatically built. Automaticity is the term. Seigler's math research findings, he showed through his research the gradual accrual of math understanding, that it built one piece on top of another. He also showed the cultural influences of practice specifics. Therefore, what was put in was part of what was processed and put back out. So memory, a couple of terms to know about memory. Sensory memory, sensory registry, is the component of information processing system in which the incoming stimulus information is stored for a split second to allow it to be processed. Working memory is considered short-term memory. It's the component of the information processing system in which current conscious mental activity occurs. Long-term memory is considered the component of the information processing system in which virtually limitless amounts of information can be stored indefinitely. So working memory improves steadily and significantly with age. Working memory, however, can be impacted by different types of trauma to the brain. Long-term memory capacity is virtually limitless by the end of middle childhood. Accessing the long-term memory will depend on constant use of those memories. So use it or lose it applies through much of our adult life as well as our teenage years. If we stop using a skill that we've learned in our brain, it may exist in our long-term memory, but the ability to access it may atrophy. Memory storage expands over childhood, but retrieval is more important. As the prefrontal cortex matures, children are better able to use their strategies to recall data. There are some advances in memory over time. Under 2 years old, the infant remembers actions and routines that involve them. Memory is implicit. My cat would like to say hi. Triggered by sights and sounds, an interactive toy, or a caregiver's voice. By 2 to 5 years, words are now used to encode and retrieve memories. Explicit memory begins, although children do not yet use memory strategies. They can remember isolated incidents. Children remember things by rote, their phone number, or nursery rhymes, or favorite songs. Between the ages of 5 to 7 years, children realize they need to remember some things, then they try to do so, usually by rehearsal, repeating an item again and again. This is not the most efficient strategy, but repetition can lead to automatization, so they remember something without recalling how they remember it. 7 to 9 years old children can learn new strategies, including visual clues, remembering how a particular spelling word looks, and auditory hints, rhymes, and letters. Evidence of brain functions called the visual and spatial sketchpad and phonological loop are some of the tools that they're using for this. Children benefit from organizing things to be remembered. From 9 to 11 years, memory becomes more adaptive and strategic as children become able to learn various memory techniques from teachers and other children. They can organize material themselves and develop their own memory aids. So information processing part 3, there's extensive knowledge base that makes it easier to master new and related information. The more we know, the more we're able to learn is the way of thinking about this. Our experience builds up, our opportunities increase, and we become more motivated to learn. And so it's easier to learn the more we know and the more we're motivated to learn. Control processes are neurological mechanisms. They require the brain to organize, prioritize, and direct mental operations. We want to store our data in a logical way. And information processing theory says that we do that in our long-term storage, our cognitive belief system. This is often called executive processes. The ability to use this is called executive function. If you look at brain scans, this would happen in the frontal lobe of the brain. It improves with age and experience, the ability to store data in a way that we can recall it. Sensory registry is that information, again, that we're getting the senses of what we see and hear and smell and touch. And then we can move that into our immediate memory and think about it, and therefore it goes into our working memory. And if it's important enough, we may put it in our long-term storage. The ability to use our long-term storage, what we put in there, develops our self-concept. Executive function, there are a couple of aspects of executive function that develop during the school age years that are important to discuss. One of them is metacognition. Metacognition is thinking about thinking. Children are able to explain their thinking process and discuss their thinking process in new ways that they weren't able to before. Meta memory is knowing about memory. Children actually understand memory, understand how it works, and have a conceptualization for how to store things in their memory. Language is a really important part of learning for children. So by age 6, children know most of the basic vocabulary and grammar of their first language, or at least the the most basic forms. They may speak a second or even a third language by the age of 6, depending on the exposure they've had. Remember, one of the important times, sensitive periods for language is 0 to 3. So depending on what exposure a child has had, they may have developed multiple languages. In middle childhood, words become pivotal for curriculum and understanding. We're using words more actively to increase children's learning. Children start to understand metaphors. School-age children comprehend and enjoy puns. They enjoy unexpected answers to normal questions, and metaphors, because their new cognitive flexibility and social awareness, make them funny. Metaphors are context-specific and build on their knowledge base. They're things like couch potato. And so that's something that a younger child may concretely try and see where the potato is on the couch, but an older child can laugh at the image of that. Adjusting vocabulary to context is something we all have to learn. At the bottom, you'll see a cartoon, "The fish is ready to eat." And there's two different contexts there. One is a fish getting ready to order off a menu and eat, and the other is a fish that you might eat for dinner. Pragmatics is the ability to use words and devices to communicate in various contexts. We use our tone, we use specific word order, we use all the different forms of communication to convey context. It allows children to change from formal to informal codes to fit the audience. For example, I don't talk in classes the same way I do with my husband or my children or my best friend, and the same is true for you. We have different contexts for different environments. You may not speak the same way to your parent as you do to your friends. Those are all pragmatics. It's how we use language. One of the roles of school is to help children learn how to use formal communication in contexts where they can display their information, their knowledge, in ways that others will receive it in appreciation of their learning. And so that ability to communicate in the context of the way we do in schools is one of the pragmatics, is one of the things that we're teaching children in their elementary school years. Code changing is a really important skill to have. Children who are bilingual or trilingual or quadrilingual have the ability to code switch. They know when to speak which language, depending on who they're speaking to. Almost 1 out of every 4 U.S. school-age children have a home language other than English. 1 of 20 speak a regional dialect of that language. All these alternate codes have distinct patterns of timing, grammar, and emphasis, as well as vocabulary, so all require much more than literal translation. Children who are able to speak more than 1 language or more than 2 languages, their brain becomes more flexible, and there's a lot of benefits to bilinguality. Code switching, or the ability to speak multiple languages, correlates with school achievement. Children achieve at a higher level if they're truly bilingual and can code switch between languages. There are no brain differences. If the 2 languages are learned in the first 3 years, children can speak both fluently, depending on how they're taught. They need to be taught with clarity, conciseness, and accuracy. More children in the United States are now bilingual, and more of them speak English well, from about 40% of the 82% in 2011. You'll see a chart here where children who speak language other than English at home is in orange, and children who speak language other than English at home and have difficulty speaking English is in purple. And you can see those numbers increasing. So we need to think about our teaching approaches with children who are emerging multilinguals, the new term we're using for English language learners. Language learning depends on the child, first of all. What's happening for them on the playground? How is their language perceived by others? Does it help them access play, or is it something that is a trigger for bullying, which is all an aspect of our adult environment and what we're instilling in children as well. It depends on the home environment. How literate is the home environment? How much is that first language being spoken in concise, accurate ways instead of being melded with the second language? The teacher's warmth and training and skill in working with children who are multilingual is really critical to children's language learning. If the teacher doesn't know how to work with children who are emerging multilinguals, they may inadvertently do damage to the child's ability to speak both languages. With emerging multilingual or English language learners, immersion is really important, and it's one of the theories of how children learn a second language best. Immerse them in the new language and they'll get it. First language instruction to new language instruction is the alternate method, where children are first introduced to school concepts in their home language and then bridged over to the new language after they've had that immersion in with their home language. They're learning in their home language. So it depends on the philosophy of the school when the immersion happens, whether it's after first language instruction or right when the child enters school. Bilingual education is different than English language learning. Bilingual education is the instruction in both languages at the same time. Usually one language is spoken once, and then the same thing is said in the second language. English as a second language, ESL, includes intense instruction with non-English speakers together. There's no use of the first language. It's usually a pull-out system where children are not included with the rest of the children in their classroom. When we come back, we're going to talk more about bilingual learning and the differences in how children learn. And we'll move on and talk more about some other concepts and what we're going to be doing this week in discussions. I'll see you in a minute.